Hello children. I hope you have seen your previous video of this unit 3, which is mechanics of solids and fluids. Right? So with that continuation, we are going to see the next contents of this lesson. So what are all the contents we learned in the previous class? We learned about stress and different types of stress. And we learned water strain and different types of strain. And we learned about Hooke's law. And we learned about elastic effects like elastic after effect, elastic fatigue. Now we are going to learn about hydrostatics and what is about pressure, density, relative density, viscosity and Stokes law. And now in this class we will learn to viscosity and Stokes law. We will continue with a little introduction we will stop. Right? Now first, what is hydrostatics? So the word itself says it is hydro and statics. See what a beautiful word it is, right? So it is hydro. Hydro means water, hydrogen and oxygen combines to make water. So wherever you see hydro, it refers to water, right? So right, then it is statics. Statics means what? In mechanics lesson itself we have seen rest, right? Water at rest. So when we study about fluids which is at rest, I'll tell you what is the meaning of fluids in the chloride content. So when we study about fluids at rest, and then it is called as hydrostatics, right? Now when we study about fluids in motion, which is moving, right? Then it is hydrodynamics. Hydro means water, dynamics means already we know mechanics of moving objects, right? And it is otherwise called as fluid dynamics. Say the word fluid dynamics. And hydrostatics is otherwise called as fluid statics, right? Simple children, study of fluids at rest, hydrostatics or fluid statics. Study of fluids in motion is called as hydrodynamics or fluid dynamics, right? Now we are moving to thrust. Before that, I want to tell you about the meaning of fluids, right? Fluid is nothing but a substance which can flow. Flow means what? We need not to push it and take it and move the object from one place to another place. When the object is placed at one subject or what is that? When it is poured at one area, and automatically it can spread in other areas. For example, what are the three states of matter? Solid, liquid, gas. In this, solids have a rigid shape and rigid size. We cannot move it from one place to another. Sorry, we need to take it and move, right? As per your first law. But what about this liquid and gases, right? When we pour the liquid in one place, right, and it can automatically flow, and even the gas, right? Now when we have some glass leakage in our kitchen, automatically we can smell it. From the kitchen it will flow to the other places of our house. So these two states of matter, liquids and gases, we can feel and it can flow from one place to another. So this type of substances which can flow from one part to another, they are called fluids. So liquids and gases are combinedly called as fluids. Okay. Now coming to thrust. It is the change in the momentum of liquid with the container. It is the change in momentum of liquid with the container. For example, I have one small beaker here. Right now when we pour the water, what will happen? Now this liquid, always the substances are made up of molecules, right? So especially the liquids are made up of molecules, right? So these water molecules, what it will happen, what it will experience, it will go and hit the walls of the container. That hitting process we call it by a word called collide. Okay. So now this water molecules collide with the walls of the container. Container is this beaker here. Now after hitting it will come back. And now the other molecules will go hit and come back. Like this, now every molecules will have some colliding process, interaction process with the walls of the container. And now due to this process, what will happen? This momentum of the liquid will be changed. Momentum means we have already learned P. P is equal to mv, mass into velocity. So the velocity of the molecule mass will be always same. Velocity inside the velocity of the water molecules will change. So by hitting with the walls of the container, the momentum will be changed. So that process is called as thrust in the liquids. Clear, children? Now when the liquids are poured in a container, the molecules exhibit some force with the walls of the container, which will result in the change in momentum. Momentum means mass into velocity, and this process is called as thrust force on the of the liquid. Okay. Next one is fluids. We have seen, children. When we regard the fluids, in your book page number 55, there is a tabular column which is very important. Now we have here this tabular column on page 55. If you have kindly take your book, underline with your pencil. We have so many properties there on page 55. Right? We have mass, shape, volume, compressibility, fluidity, rigidity, diffusion, space between particles and interparticle force. In this, at least 5 or 6 you have to be very thorough because it is a detailed tabular column. Right? So first mass you know, right? Shape you know, volume you know, compressibility. Compressibility means how the substance can be compressed. For example, this box, if I compress, if I apply a force, right? So how much it can be pressed? This cannot be pressed very easily, but a sponge can be pressed very easily. So compressibility is more for sponge. For this it is, compressibility is more there, and here it is less. Easily it can be compressed. What? Sponge. Fluidity means how much it can flow. For example, what is that? Liquids, coconut oil if I flow here, pour on the table, right? And water. Compare the flow of this. Which can flow more? Water can move fastly than the coconut oil. So this is called flowing ability. So that is called, that flowing ability is called as fluidity. Next one is rigidity, how stronger. Then diffusion is that spreading in the air, right? Like we smell we feel the smell of incense stick. No, in Tamil we say uduvati, right? So that how the particles are spread out in the atmosphere. That property is called as diffusion. Space between the particles. So if the molecule liquid is made up of molecules. What is the space between the molecules and the particles? They are the last two one. What is the force between the particles or molecules is called as interparticle force. So in this, out of 9, you have to be thorough with at least 6. Okay. So for solids, liquids and gases, how it will be, it is given in the book. Right. Next one, we are moving to pressure due to a liquid column. Now, when I pour, see, I am going to pour water in this beaker, children. Now just see. Now this is liquid column. So this phase is called as liquid column. In this liquid column, what is the pressure and how the pressure will be? What is the characteristics of the pressure in this liquid column? So that is what we are going to see now. Right? So this liquid column pressure is equal to a factor, 3 factors which are called as H into rho, the symbol. What is that symbol here? So we will write like this, right? Right. Like a hook, right? So that we call it as rho, R-H-O or R-O-W for your pronunciation, right? H, rho, G. Okay, I'll tell you what is that. H is the height of the liquid column, right? So how much height, to what height we are having the liquid. Rho is the density of the liquid. Density means thickness of the liquid. We are going to learn what is it. And then we have G. Already we have learned this, acceleration due to gravity. Equations of motions and all we have learned now. So it is 9.8 meter per second square. Do you remember that? Yes. Acceleration due to gravity. So what is the formula for P? P is equal to H rho G. H means height, rho means density, G means acceleration due to gravity. That is what I have written here. What is the unit for it? Pascal. For height it is meter. For density it is kilogram per meter cube. Say kilogram per meter cube. Have a note of this in your notebook or your textbook. Right? For density it is kilogram per meter cube. For G it is meter per second square. What is that, children? For G it is meter per second square. Right? Next we have density. We are going to see what is density. It is the form density. Symbol is what I said here. Rho. RHO, and that is that bent hook. Right? Density is equal to mass by volume. What is its unit? Kilogram per meter cube. Right? So what is mass? It is what is its unit? Kilogram. And what is the unit of volume? It is per meter cube. And this volume is in the denominator, so it will go up with minus symbol. This and all I have told you in the earlier classes. So kilogram per meter cube. Right? So this is called density. What is density? It is the thickness and it is the ratio between mass by volume. Mass and volume. Rho is equal to m by d. Say the formula for 5 minutes by within your heart after passing the video. Right? Next, what is the unit of density? Kilogram per meter cube. Now we are going to see another formula which is relative density. RD I have written, which is called as relative density. Okay? Relative density means it is the ratio between density of a substance with the density of water. For example, I have this water, a small amount of water, and if I have kerosene, right? Kerosene means you know, right? Manana, you know. So that too we are going to compare the density. So when I compare the density, we call it one term by a word called relative density. That is equal to density of substance means what is the substance here? Kerosene. Density of kerosene by density of water. Right? So if I find this value, we will get one number. It is a mere number which doesn't have any unit. Why it won't have any unit? Because this is also density. Denominator also density. This will have kilogram per meter cube unit. This will have kilogram per meter cube unit. Both will get cancelled because relative density is a ratio of similar quantities. Density. Right? So they get cancelled. That's why relative density will not have unit. What about the unit of density? Kilogram per meter cube. What about relative density? No unit. So keep this in your mind. Okay. Now in your book, page number 56, turn the page. We have another tabular column, right, which will say you about the differences between density and relative density here. This tabular column, right? So that whatever the points we had discussed now, that is what is given here. So have learn mark that tabular column also. I will give that in the notes too. Right. Next one we are moving to see about viscosity. Right. So saying this density, children, I will show you an activity after this video. Right. So now viscosity is that. Now in this diagram, a symbolic diagram. See this liquid, right? So we'll have so many layers in it, like this. The 3-dimensional way will in a 2-dimension I have represented here. The 3-dimension you can view here. It contains so many layers of liquids. In each layer there exists some force. That force we call it as frictional force because it is acting between two layers. So force between any two substances is called as frictional force. Already we learned, right? So now this frictional force acting between these layers is called as viscous force. The frictional force offered by the layers of the liquid is called viscous force, and this phenomena of exhibiting the viscous force by the liquids is called viscosity. Say the word viscous force, and the phenomena is called viscosity. Right? And it is denoted by a symbol like this, N, and N you should extend like this. And we call that symbol to be eta, not eta, right? EATA, right? So its symbol is called as eta, and you have to write like this. N you have to write the at the end you have to extend. So how do we call it? Eta. Now two symbols we have learned. Here density we have learned rho, rho. Here we are learning one symbol, it is called as eta. How we have to write? Pronounce it eta. Eta is what? Viscosity. Right? And what is this unit? This formula and you will learn in your higher classes. Now know the unit number. The units are underlined in your book too. Newton second per meter square, kilogram by meter second. These two are SI units. Poise, P-O-I-S-E in CGS system, and decapoise and poisson. These are all another common units. Right? So decapoise are poisson. Poisson. Say the word poisson or decapoise. So what are the units? Newton second per meter square, kilogram by meter second. Poise in CGS system, decapoise and poisson are other common units. Underline this, very important 1 mark points. Now here conversion we need to know. One poisson and decapoise are similar. Right? So one poisson is equal to one decapoise and one deca. Deca means what? 10. Right? Decade. One decade means 10 years. Like that, one decapoise is equal to 10 poise. Underline that in your book. Right? Now, viscosity will not have any direction, so automatically it is a scalar quantity, not a vector. It is like viscosity is a scalar quantity. Now, here we have one another term called relative viscosity, that is equal to viscosity of liquid by viscosity of water. Relative viscosity is the ratio between viscosity of liquid and viscosity of water. Right? Same thing. Now I said no, kerosene and water. If I take the viscosity of kerosene and divide it with the viscosity of water, then it is called as relative viscosity. Here relative density means the density of water, viscosity means viscosity of water. So relative, if you see the word, we have to compare it with water in this lesson. Right? Next one, we have the streamline flow and turbulence flow. Streamline flow is nothing but when you open your tap, right, water is coming with a slow speed means, right, you have to turn a little, not fully. The water will come like one complete steady flow, steady and slow flow without any violence, right. If the flow is like that, it is steady and each and every particle will have to follow the same path. If one molecule is coming and followed by the other molecule, right, all will follow the same path, right, and velocity of one molecule will be transferred to the other molecule and all the molecules will travel with same velocity. So that is what I have given here. So they will travel the same path, right, and each and every molecule will have the same speed, right. So if the flow is steady, like what is that? We have water in a lake, right? So the water will be standing still. So that type of flow is called as streamline flow. But if you open the tap in a full, complete open way, then the water becomes what? Disordered. The speed becomes what is that? Varied. Each and every molecule may have different speed, right? Then the speed, that abrupt and violent flow, we call it by one word called turbulent flow. Say the word turbulent flow. So it is not a steady flow. The flow will be disordered and it will have the water molecules will have different velocities. And now this streamline flow, we call it by another word called laminar velocity, laminar flow, right? So a streamline means it will be slow and steady with same velocity, same path. Turbulent flow means what? It won't be steady and the flow will be disordered. And one example, good example I can tell you, it is also given in a book. When you just ignite your incense stick, that Uduvati I told you already, that first in the beginning what it will do? It will regularly rise up, and then after that few minutes what it will do? What it will happen? It can spread out in all directions, and that steam of what is that smell, right, will move around at different speed. So till one particular point the speed will be steady, which is streamline. After that it becomes turbulent. Okay, and now floods in water, right? If there are no floods, heavy water will not come. So the water will go with a steady flow, and if sudden high rain and high flow of water comes in, what happens? Water will flow with floods with a great speed. So then the speed becomes turbulent. Okay. Now here this is streamline and turbulent flow, and streamline flow is otherwise called as laminar flow. Right? And now we have one number called critical velocity. Right? Now till one particular point the liquid will have a steady speed. That is what I told you now, instant speed. No. Till one particular point the speed will be steady. After that it will become turbulent. Right? After that I am saying no. After what? After one particular velocity, the molecules will change from streamline flow to turbulent flow. So that particular velocity which will change the flow of a liquid from streamline type to turbulent type, that is called critical velocity. Say the word critical velocity. Right? Next one we are going to see about Reynolds number. Reynolds number, right? It is denoted by a letter called NR. N subscripted by R. It is just a mere number. Seeing the number, if it is having a low value, we can say it is a streamline flow. And seeing if it is having a high value, we say it to be a turbulent flow. Right? So Reynolds number will tell you what type of flow a liquid will have. Okay, children. So these are the concepts we are required to see today, right? So note down all the concepts. We will proceed with the activity. Children, I told you that I will proceed with an activity, right? Now I have a beaker, and we are going to discuss about how density will help the liquids. How density will impact the liquids, right? Now first I have a beaker, right? Now I am going to pour some water in it, right? Can you see it? Yes. Now after that water, first observe the activity, then I will explain. Now I am going to cut this oil, cooking oil. I am going to pour it. What are you expecting? Will it get mixed up? Just watch. Right, now you see, children, is it getting mixed? No. You can easily see this is the layer of water and this is the layer of what? Oil. Right, now I am going to pour another liquid, which is a cleaning liquid. Right, now just to see. See, children, that cleaning liquid is separately seen now. Now see. So now the cleaning liquid gets down. Water is in between. Now the cooking oil is at the top. Why, children? What is the reason? Can you guess? Now the liquid gets dissolved in water. Now different change will come. Now I will explain you the reason now. Now the water will have one density. Cooking oil will have another density. And this cleaning liquid will have another density. Now in the beginning, as I poured that cleaning liquid, it was like one bulge, right? After that it got sedimented like this. Now you see it got started to dissolve in the water, right? Now this is because due to the density, different densities for the liquid. Water will have one density when compared with the liquid oil and the cleaning liquid, right? So because of this difference in the liquids cannot mix with each other. And also the water will have one type of viscosity, that what is that? Adhesiveness, thickness, right? In Tamil we say to be vazhavazhappu thanmai, right? So with that, water will have one type of viscosity, liquid oil, that oil will have one type of viscosity, and this cleaning liquid will have one type of viscosity. Due to that character also, the liquids cannot mix with each other. So this is how density helps in us children in our daily life. Okay, thank you children.